when solving trig equations, we are trying to find the values of the variable in the domain of the equation that make the equation true. So with trig equations, they're different than trig identities. Identities are true for all values in the domain, and equation solving is finding those values in the domain that make the equation true. Now, when we're doing the solving of trig equations, there's several things we need to consider. First of all, we need to really make sure that we keep our thoughts on how we solved equation types in our algebra, because we'll need to use those sorts of techniques as we're solving our trig equations. We also need to keep in the forefront of our mind our trig identities, because oftentimes you need to do a replacement with the trig identity to be able to work with the equation in a manner that you'll be able to find the solutions for it. So you want to think, okay, how did I solve these types of equations when I'm doing algebraic equations? What are trig identities that I have in my disposal that might help me get to the solution of the equation? And then the other thing that you have to do is look at what form of the equation true are you supposed to leave your answer in. So when you're looking at how should you leave your answer, you really want to try to see if there's something that tells you about the way that your variables need to be reported. So in the example that I'm doing today, it's telling me I'm supposed to give my values of my variable in the span starting at 0 up in 2 but not including 2 pi. So I need to give it in radians and then just one rotation around the circle. If it didn't say specifically how to leave it, then I would need to make sure I would give the values for not only the first time around the circle, but also add onto it any multiple of full rotations that would also give me a coterminal angle with those. If it told me that the span was from, say, 0 degrees to up to but not including 360 degrees, then I would leave my answer in degrees. So always be paying attention to which form they also want you to leave your answer. Now with these three general things in mind, let's look at these examples. So the first one is to solve sine 2x is equal to cosine x. Well, there's not that much that I can do algebraically with this. There are different trig functions, as well as on the left it's acting on the sine of 2x, and on the right the trig function's acting on x. So I don't even have the same angle in each of these. But I do know that there is a trig identity replacement for the sine of 2x. It's a double angle identity. And if you don't quite have those fresh in your mind, I've put links to videos that go over those identities in the description of this video. Well, sine 2x's replacement is 2 sine x cosine x is equal to cosine x. Now I want to think of what did I do when I had a problem in algebra when I was trying to solve a product equal a product and I needed to find the values that would make it true. Well, I can't divide both sides by cosine x. Cosine x is 0 for some values of the variable, and you can't divide by 0. So what you do need to do is subtract that cosine x from both sides to get 2 sine x cosine x minus cosine x is equal to 0. And now on the left hand side I have this two-term expression that has a common factor of cosine x. So that's 2 times sine x times cosine x and then minus cosine x. So I'm going to factor out that common factor of cosine x, and that'll leave me a 2 sine x in the first term. And when I divide cosine x into negative cosine x, I get a negative 1 in my second term. Now, when a product of two things is equal to 0, that means one or the other of the factors has to be 0. So cosine x equals 0, or 2 sine x minus 1 equals 0. But when I take this 2 sine x minus 1 equals 0, I will add the 1 and divide by 2. That will give me that sine x has got to be 1/2. So now I just need to figure out what angles would make this true in the way they want me to report my answers. So what angles in the span from 0 to 2 pi have a cosine ratio of 0. Well, cosine is 0, remember, when my angle is pi over 2 and when my angle is 3 pi over 2. So x is equal to pi over 2 or 3 pi over 2 for the cosine x is equal to 0, or sine x is 1/2. So what angle's in the span from 0 just until you get to 2 pi is the sine ratio 1/2. Well, remember, sine is 1/2 at the pi over 6's that are simplified in radians, and positive 1/2. Sine is positive in the first and second quadrant, so that's going to be at pi over 6 and at 5 pi over 6. And if you'd like, you could go back to, if you learned how to find your trig ratios by looking at the unit circle, you can kind of look at the unit circle and read that backwards, remembering that the sine of the angle is the y-coordinate on your unit circle and the cosine of the angle is the x-coordinate on the unit circle. So for our first one, our values are pi over 2, 3 pi over 2, pi over 6, and 5 pi over 6. Now let's look at part B. So this is 2 sine squared x minus sine x is equal to 1. Okay, so think back to remembering that sine squared x means that it's sine x squared. So what would you have done if you had 2a squared minus a is equal to 1? So this is that algebra thought process that you often need to use when you're looking at solving the trig equations. Well, this is quadratic in the variable that we're working with, and it's the same here and here because it's sine x that's squared and then just sine x to the first. Well, quadratic equations I could solve by factoring, if it's factorable, completing the square, quadratic formula, any of these. So what I'm going to do is solve this by factoring. To solve it by factoring, I need to get a 0 on the right-hand side. So I have 2a squared minus a minus 1 is equal to 0. And then whichever way you learned how to factor trinomials, I also have videos on trinomials and factoring trinomials if you need to kind of refresh that. But we're just going to look at it in terms of guess and check because there's not that many options here. So to get 2a squared, you need to place what would go in the first terms to create 2a squared. So that would be a 2a and an a. And then the outers combined with the inners give you your middle term, but I need my middle term to be negative. So the one with the bigger coefficient has to multiply to the negative factor, and the one with the smaller coefficient has to multiply to the positive factor, and it's plus 1 and minus 1 to get a negative 1 at the end. Now, that's how we would have factored in algebra. But a is just taking the place of sine x in our trig equation. So we really have 2 sine x plus 1 times sine x minus 1 is equal to 0. Now setting each factor to equal to 0, I have 2 sine x plus 1 equals 0, or sine x minus 1 is equal to 0. In the first equation, we'll subtract 1 from both sides, so I have 2 sine x equals negative 1. Divide both sides by 2, sine x is equal to negative 1/2. Or, second equation, add 1 to both sides, sine x is equal to 1. Now again, I'm supposed to give the angles in the span from 0 to 2 pi, for which the ratios of these trig functions come out to be that right-hand side. So, what angles have a sine ratio of negative 1/2? Well, the half for the sine ratio happens at the over 6's. But to be negative 1/2, I need them to be down. So they need to be in the third quadrant or the fourth quadrant. So I need to go to 7 pi over 6 or 11 pi over 6. And what angle has a sine ratio of 1? Well, the sine is positive 1 at pi over 2. So those are the values of x that make this original equation true. Okay, and then our third example for this video is 4 cosine squared x minus 3. So I just have the cosine squared x term that has the variable in it. So what I could do with this one is solve that quadratic by the square root property. So remember, when I have something like, and I'll put this one off to the side so I don't run out of space there. So like 4a squared minus 3 is equal to 0. When I didn't have a term with a in it, but it was quadratic, I could solve for the squared term. So we're going to add 3 to both sides and get 4a squared is equal to 3. Divide both sides by 4. A squared is equal to 3/4. And then take the square root of both sides. And when you take the square root of both sides, you have to remember your plus or minus. So this is a is equal to plus or minus the square root of 3 over square root of 4 is 2. So that's what I would have gotten if it were a. But it's cosine squared x that we have here. So we're going to shadow these steps. So we will add the 3 to both sides. Divide by 4. Take the square root of both sides, remembering the plus or minus. So cosine x is either the square root of 3 over 2, or cosine x is negative the square root of 3 over 2. And then we just need to think of our angles throughout the rotation that would give that. So what angles have a cosine ratio of the square root of 3 over 2? Well, those are the ones that would be right of the y-axis. And that's the over 6's then in the first quadrant and the fourth quadrant. So that would be pi over 6 and 11 pi over 6. And then with which angles have a cosine ratio that's negative the square root of 3 over 2? Well, that's still the over 6's, but now they are left of the y-axis for your x-coordinate to be negative, and cosine goes along with the x-coordinate on the unit circle. So that would be the second quadrant angles and the third quadrant angle with the over 6's. So that would be 5 pi over 6 and 7 pi over 6. So that gives you 3 examples of solving trig equations. In another video, we'll do a few more types of solving of equations.